Hello, welcome back to class number 7 of Nuke Immersive VR Compositing, nuk234. I'm your Professor Daniel Smith, and we are going to be finishing our shot today and kind of doing the last few passes and getting them into the mix, spending some time to finish a shot off. We're going to go through the main comp. I'm going to talk about the render layers, but pretty much we're trying to get this shot done so we can get it back into our VR environment and then work on that and get the complete experience finished. All right, so here we are back in Maya, and I want to show you what we have set up here and the things that we've added to our environment. You can see it's primarily the grass, and the grass is really nice to help sell the shot and get him more integrated into the forest. The grass is primarily paint effects that has been converted to polygons, and really easy to paint this stuff onto the mesh. And we added this in, and also over here, this is really important, is just a few little rocks, a couple boulders in the scene like this guy back here, but most importantly is the rock right here because it solves a problem. That problem is earlier in our animation, when he's curled up into a ball, his foot was floating because it was posed in a way that it was supposed to be sitting on a rock. So I had to place a rock into there and set it up in such a way that it rendered with shadows, rendered with occlusions, so that way he would be properly posed when he stands up. And before, especially in stereo, before he takes that step forward, you could really see that his foot back there was floating. So this was the creative solution to that problem. Today we have a couple of different render layers for you. I set up a grass render layer, which is just rendering out the grass pass with everything with a black hole shader on it, so it occludes, so we can kind of just put the grass down on top of the existing render layers. Then we also have a grass mat, which is just a couple tufts of geometry of the grass that is directly in front of our troll. So that way I can put some grass back on top of him, because what we did is we took his render layers and we rendered them from a different point of view. Remember, we changed our distortion amount. So if we go to our stereo camera, and you can see that this amount of distortion is our value of 0.19, but all the troll render layers were done at 0.39. So the grass mat is also being rendered at 0.39, so it matches the troll's render layers because it has to go in front of him, not behind him. So the rest of the grass, which goes behind him, was done at the wider render size. And then we also have our grass shadow pass, and this is set up like shadow passes were before, where the ground mesh has a use background shader and everything else is unseen by camera, so that way we get just shadows. And then I also have a rocks shadow pass, which is right here, and I had to include the troll in this because I wanted the rocks that the troll is casting on the rocks to be included with part of the pass that's actually going to be casting shadows to the ground. And then of course there's the rocks pass itself, which is just the rocks in the environment with everything else cutting it out. So these are the layers that you're going to be receiving today, plus a dust layer. The dust layer was created in Nuke, and I will be going over that a little bit later. Now, this is how everything comes together, and I just wanted to show you what the end result was going to look like before we get there. And you can see the grass and the new rocks are in here, and we've got this little dust coming down through the canopy. Now let's pause this and let's go to our render layers. These are the new render layers that we've created for today. We've got our rock pass, which has the beauty lighting and everything on it. And we have our grass pass, which you can see is the grass with black hole shaders to block out the troll, the rocks, and the trees that are in here. So that way this can sit on top of the other background. There's a pass called shad mats because these are a new shadow pass and mats for all of our stuff. So in the red channel, these are the shadows for the grass. So we can add additional shadowing from the blades of grass. And in the green channel, this is a new rock shadow pass, but it also includes the troll. So we had a previous troll shadow in here that we're going to substitute this one, which includes the rocks. And then the blue channel has that foreground grass. That foreground grass, which will go through the other process. Now, I could have used it from the other one, but one of the big things is when you look at how fine these blades of grass are, we're going to definitely get an issue earlier in the project over here when this whole area, which is, let's see, hold on, Control and Shift, this whole part of the screen is a whopping 560 pixels. And when it gets screen corrected through VDI, we're going to end up getting a 1920 image from those 560 pixels. That's a enlargement of 4 times the size. And because these are very tiny pixels, we're really going to get some chatter in those. And that's okay, because even though in the final render it's going to look a little chattery and it's going to look a little blurry, but remember, it's always meant to be seen from a greater distance away, and you'll never see that sort of artifacts up close and personal, because as we get closer and closer, the resolution gets a little bit better. However, because the layer ordering, because we're going to be putting the grass over top of the trees and the ground, and then we have to process the troll separately because we wanted our hero to have a higher resolution, it's kind of hard to matte him out effectively with these pixels. So the idea here is to take this higher res matte and process that separately, so that way in the end we have more pixels to cut him out with and put the foreground grass back on top of him. So I hope you can follow along with that, but it is just maintaining consistency as far as depth from the background to the foreground. And because this is in front of our troll, and our troll's hands are in the grass and over the grass and in front of the grass, I wanted more resolution. So it seemed like a better idea to make this more consistent with that. All right, so let's jump over here. And we're going to take a look at the first thing, which is those shadows. So we have our pre-existing shadows right here. And we're going to feed into the color correct. And we can see that, we've already got our shadows in here. Now, this time though, the troll shadow also adds these rock shadows. So we've got these big boulders right here and the smaller boulders that are helping support his feet. But then we also have our new grass shadow. So that's where this comes into play. And you can see I just added that in. So added that in, but gave it a little bit of blur because it just was a little sharp in places. But we do lose a bit of detail there. So what you want to do is be very careful with the blur and maybe even animate the blur. So when you're much closer in the camera, we can have a little bit higher amount of blur. Let's see, like 2.1. And then keyframe it. So that way, when we get really far away and the blur really needs to be less than, it can then animate between those two values as we move. Because a blur is it blurs based on the amount of pixels. And because this image is moving dynamically, the amount of pixels that it has to blur is going to be far less at the beginning of the shot for that. So you don't need as severe a blur because then you're going to just lose it all. So it's a much better idea to animate those. And if you do animate them, give them a little ease out and ease in. So adjust those tangent handles in your curve so that way it doesn't just suddenly start. It'll be a little bit more natural. So we have our shadows. And now we need to bring in our rocks. So the rocks are over here. And I've got a slight color correction on it. Let's see where it comes in. Right there. And that looks much better. I have a roto over here because, well, let me just show you. Okay, so I turned off a couple of these nodes here, and I want you to see what's happening. So in my infinite wisdom, when I rendered my layers, I forgot to properly occlude this particular tree. So what happens is, because I did not have the foresight or clairvoyance to understand that I was going to put a rock here when I rendered the trees, the rocks over here, which are in front of the trees, including this one in the background here, or it's over here somewhere, it never was a problem. But this one back here is a problem because it occurs in front of this tree and before we saw all the way to the back. So when I put the tree layers on top, this doesn't work. So that right there is a problem. So I solved that problem by creating a roto on the rock layer itself, and this roto is set to minus mode right here, minus. So that way, when enabled, it gets rid of all the other alpha channels. So it gets rid of everything else over here and allows me then to do a few things here. So I'm going to clamp this because when you use a minus, I want you to see that the alpha channel values are now in -1 where it subtracted from that. The areas where the alphas were are now at 0, but everything else is at -1. So that can cause a problem. So you want to drop a clamp node there so everything is equalized back to 0 and 1. And then we have then we're basically taking over here the alpha of the trees, And we're running it through a channel merge, and that channel merge is set to stencil. And stencil is going to use the 1 alpha of the rock and subtract it from the alpha of the trees right there. And then that allows us to put the trees on top here. But we do have a little gap right there because it should have been rendered together and not rendered in this way. We need to, oh, and you can see there's like a double image right there. So we need to pre-mult that. So you can see that there's a pre-mult, which gets rid of those edges. I've got a edge blur that's just softening the edges of the trees. And then up here, I put a dilate on the alpha. So I dilate that one little edge out to fill that gap. And that solves the problem. All right. Sometimes when you don't think of like, well, hey, you know, setting all those render layers up at once, sometimes you miss something. And instead of having to re-render that entire layer, which would probably yield a simpler result, but you would have to re-render, sometimes you have to get the deadline finished, and you just kind of go through it and find a creative solution that solves your problem. Now we are going to look at our grass. So we've got our grass right here. And let's go to a different frame. There we go. So we've got our lovely background, and we've got our shadows all there, and our rocks are properly comped in. And this is where the grass comes in, and you can see how it's designed because of all those black hole shaders to just sit on top of everything, but it can be both in front of and behind things because of the black hole shaders that we did for that. Now, a more elegant solution to something like this is something like deep compositing, but deep has such a huge data footprint, you know, not having to do holdouts. And the black hole shader on everything is basically a holdout for what goes behind and what goes in front. Anybody's interested in how to set that up, you can ping me in the forums and I will let you know. Right here, you can see how that's working out, but I wasn't happy with the color, so I kind of pushed it a little more towards that green color to kind of, I did initially in my shaders some variations, but this is just pushing it a lot more towards a kind of more of a uniform green color that matches the moss and the different kind of leaves and the overall look that I'm going for. And I was trying to make it more consistent with everything else. And that just wasn't happening with that. So now this goes through our zero blacks, and down here is our fog. Now, the fog, I thought about like, well, do I need PMAP for the grass? Do I need PMAP for the rocks? And for the most part, no, I don't, because it's giving a pretty consistent look around here for most of this, except we had one little problem with the PMAP, and that was this guy right here. That same rock that was a problem with the other stuff was it needs to be represented in the PMAP. So I thought about just rendering a separate PMAP just for that rock and to combine the two together. And at that point, it just became like, well, let's figure out a more creative solution. So if we go back up to here, you can see right here, it says class 7 rock PMAP. And this is my creative solution to that problem, which was in essence to fake a PMAP section right here. Essentially, if we look at the PMAP and red, green, and blue, right? Our blue values are basically describing where something is in depth. And because we're using the PMAP to generate a depth atmosphere pass, and down below you can see that we are basically, shuffling it out, and then we're creating this right here, right? So we're creating this atmosphere from our PMAP. And what we need to do is just include that rock in there so that way it doesn't do this to it. So if I look at the values right here, and we determine where in the position is that rock, it's about right here. So I'm going to put my cursor right about here. And we're going to go back to the PMAP, and we can see that our values are about -57. If I go down lower to about the base of the rock, you can see that says about -48, right? If we go a little bit lower, you can see about -40. So that's our Z position for that. So based upon that, the idea is that we're going to take that rock that we already did earlier, and I'm going to pre-mult it to get rid of the other ones. And we're going to shuffle it. And what I did for a shuffle was I just simply copied the alpha channel to the blue channel and everything else to be empty black. Now, I did that because if I use the RGB values are already all over the place. So this makes that more consistent for that rock being at that depth. And then I have a grade node that's grading that to -40 because that value was at 1. So by pushing this back another -40, that basically puts it back in space. And you can see the RGB readout down there says -40, even though it looks black. And then the next node just simply brings back that alpha channel back in, so that way it composites correctly. And over here, I got it merged on. I didn't include green, I didn't include the red, just simply blue for it going back in space. But when we look at our fog, you can see now it looks correct. That's without it, and that's with it. It's visually correct, even though it's technically incorrect. And that's just a way of, again, solving the creative problem visually. And the best solution would be to run another PMAP with that included. It's a pretty significant render, but for what this is, that solves it. And it's done. And the other rocks look great. So now that's done. So that's what these nodes over here are doing. All right, so we come down here, we're adding a little green fog. Everything's getting a little blurry. And we've got our particle dust over here. Now you're going to see the particle dust is a fairly complex little operation. And I went ahead and I actually wrote this all out. This was a 4.5 hour render for this particular section. And it was pretty significant because my particle emitter has to start about 1500 frames earlier to run up, and to get enough particles in the system to generate the dust falling in the air, it needed a lot of particles. It needs a lot of geometry to create the proper holdouts. And in my scanline render, I increased the anti-aliasing to the maximum of high. Now, scanline renders are normally set to none, but with each iteration, it does take a higher amount of time to render. So it's pretty massive to render a 4K image through the scanline render with super high anti-aliasing. So let's take a look at what this is though. So I started with a constant and created a roto of this little shape. And we have a card right here. And this card is my emitter. And the card is set to be above the trees and come out slightly from the screen. And you can kind of see it right there. I've got all my holdout objects in here. And the card is the emitter. So it's emitting these particles downward from the card. And then we have, in the emitter, it's emitting by 0.5. We have a 1500 lifetime particle life. Our size has some variation from 2 to 0.5. And our velocity is 0. Because I'm using gravity to pull it down. So gravity's pulling it down at 0.000001. And we have turbulence on here of 0.005, 0.001, 0.005. So that way the particles are moving around, kind of falling gently. Now, up above we had our troll in here. And I'm using him to block out some particles. So I have a new apply material node with a node called a film mat. I haven't discussed film mat before, but what film mat does is the exact same thing as the surface shader in Maya with all the values set to black, or what I call the black hole shader. So by applying these to the screen mask, to a piece of forest geometry, which has all the trees, and the troll, I'm essentially creating holdouts inside of Nuke for each one of these objects. And we're putting them all together into one scene and then running it through the scanline render. But you can see there's so much geometry in here, and there's so much so many particles that this really does end up going fairly slow. I can hit play here, but you can see that, you know, I don't have a horrible machine. I have a 4 gigahertz 8 core machine with 32 gigs of RAM and a good video card, but you can see that it's still chugging along painfully. All right. What I did here is and I'm going to disable these, is write it out. So that way it's already computed. It's in today's downloads. So let's take a look at what that looks like. So let's bring that up full screen. And we can see that we've got this little particle system that has this dust that's falling from the forest, and it's just gently drifting down, right? And what's really cool is this is going to add another level of stereoscopic fun, because each one of these particles is at a much different depth throughout the shot. And it's always really cool. Some of the coolest shots in stereo movies are like the shot in Avatar where all the little dandelion things are floating above and lighting up the scene, or in Guardians of the Galaxy when Groot puts out his little fireflies. And, you know, for when you get little tiny particulate floating in the air in a stereo shot, it really enhances the overall atmosphere. Really works well. If you're doing an underwater shot, you might have bubbles. Anytime you can put dust in the light, it really does help. But this dust needs to go on top of everything else. So we need to process this much like the God rays were the other day. So right here I have the dust being shuffled into a new layer called dust. And then we have a copy node right here set to copy the layer dust. All right. So that way, as when we go through our screen correction and this gets rendered flat, we will have a dust layer that we can utilize. And if I go down to dust, there we go. Now we have our dust, and it is in stereo. So we can see the parallax right there. So awesome. So now we have our dust coming through there. Now up above, we have our troll, and we have to do the exact same thing with our foreground grass mat. So this is where I'm shuffling that mat into grass mat layer, copying it into our stream. So that way we have our troll, we have our grass mat, and this is getting processed by the 3.9, or I'm sorry, 0.39 screen correction. And you can see the grass mat is now down here in perfect alignment with our troll. So let's skip over the motion blur for now. We'll come back to that. And this grass mat and the dust and everything else is being integrated into here. So we have our troll being comped into there, but now we need the grass put back on top. Well, actually, that's what's happening right here. Is this right here is bypassing and shuffling out the grass to RGB and alpha. And it's coming into here as a mask on that over. Now, previously, the over did not have this mask. But now you can see that's adding that grass back on over top of his feet, both over here and there. His hands happen to be in front of that clump of grass. And this also brings up a very interesting thing that we're going to be dealing with next week, which is his hands are off the edge of the screen. And in fact, they're supposed to be. And in stereo, they're coming out. And we're going to put some elements inside of our 3D environment that will help hide the fact that he's put his hands outside the screen. It's going to further enhance the shot. If we go to an earlier frame, you'll be able to see that the grass is in front of him right there. All right. And that solves that problem of integrating him behind that. So we're bringing that around and back in. Now, this blur right here is processing the whole thing, but not that matte. So we might want to put this right here, so then that blur also blurs part of that matte and makes it a little more consistent. So I'll bring that down like that. And we can get rid of that dot node. Okay. So we've got our edge blurring. And we've got our God rays that are coming back on. And then right here, this is our dust. Our dust is coming out and over. And you can see our A input says dust, our embedded dust channel. And I mixed it down to 0.19, so it's fairly light. And that's the whole idea, is we want it to be very, very light. And you can see the little particles are right there, and they're dancing through the scene. And a lot of the particles actually get lost in the light, but that's okay, because we only want to see them when they're against something dark, like real life, and the light catches them. And then we are finally writing it out. But we also have, and you can kind of see the keyframes up here, is I set up a motion blur on his big attack when he jumps up and he swipes at us. So this motion blur is keyframed, and And let's go down to our curves. And you can see it keyframes from 0 to about 0.3 shutter, and then it goes back down to 0. And the main reason I'm doing that is because it's such an intensive render that it's needed when he takes a swipe, but it's not needed as much for the rest of it. And if I had like a couple days to let this render with motion blur on the whole thing, I probably would. But again, it's more about being creative and putting things where you're going to get the most bang for your buck. This gets split from 0 to 1, and what's being keyframed as well is a switch node. So I've got a switch node on here too, turning it to the motion blur area and just bypassing it. That way, it won't affect any of the slow down any of the other renders. Even though that it's turned down to 0, I suspect sometimes it does. So I try to put these in. Plus, there's also a great trick that you can do where you can put an expression in a switch node, which is $GUI, GUI, and what'll happen is that particular switch node will only flip to the other parameter when you submit it to a render farm or rendering it via command line. That way, if it's interactive, it'll be always turned off. So when I have access to a very large render farm, that's what I always do, is I put those in so I don't see them when I'm working. But when you send it to the farm and you have that resource to be able to render so much more very quickly, it will do that. And I usually do that with vector blurs, motion blurs, anything that's really resource intensive. All right, so go ahead and render this out. When it renders, it's going to take about an hour and a half to comp it at this juncture. But it is 400 frames. It's processing at 4K, stereoscopic. Gonna probably do a few more tweaks here and there, but for the most part, our shot is complete. And you can see the little dust particles are raining down inside the forest. And it adds a nice stereoscopic punch to it. Now you can see the chatter that I'm getting in the grass at the beginning of the shot. And that's because we were dealing with such low resolution that it starts to really break down. Now, I'm thinking about re-rendering the grass pass with the higher VDI correction, but at a certain point, it's not, because you're punching in, you're not going to get like the entire shot contained within that frame. Might be able to get like from about here to maybe about here, and it might take care of this stuff right here that's chattering really bad. But again, you have to weigh the good and the bad, and remember that when it is chattering that bad, you're going to be about 50 feet away from the screen in the ride. You're never seeing it from this point of view. That's the important concept, is that the point of view is why we're doing all this. So that way, when you are in here and you're doing these sorts of things, that you're seeing it from a different, the image is being catered to your exact view. So I'm probably going to do that just because I like to be a little bit more of a perfectionist, and it's bothering me. But in the end, it'll be okay. So we're going to proceed forward. I can't wait for next week because we're going to map this sequence in stereo 3D back into our environment. And we're going to use Nuke to build up our 3D environment and create a 3D environment inside of Nuke, and put the green screen, put the screen, our view dependent imagery screen in there. We're going to bring in the motion base and we're going to build out everything and make it beautiful. And most importantly, we're going to go back into Maya and animate our motion base. We're going to get some animation on there. The main translation of the path stays the same, but now we can add a little bounce, a little push towards the screen, a push away. As we move away from the screen at the end, it's going to spin around and go down, face the other way of the tunnel, all sorts of things like that. So we're going to add that element back in and have a lot of fun with it. So until next week, hit me up in the forums if you have any questions at all. I'm looking forward to interacting with you, and thank you so much.